Hi, Midge. Hi there. Okay, good morning, Epidemics. I hope everyone's doing well today. So we'll start, as always, with our announcements. I have posted your assignments for this week on Blackboard. There's a quiz and a journal prompt. They're both due Sunday before midnight. The quiz is open note, so you're free to use your notes or a copy of my lecture notes. And the journal prompt is very much opinion-based, so feel free to state your opinion. I'm looking with the journals, I'm looking for signs that you thought about the prompt that I've given you. And I want you to, give me a decent length little writing about that. I don't need multiple pages, but I would like some clear evidence that you spent a little bit of time on it. There is a reading assignment this week. Please read that before class on Thursday. I'm going to have you guys go into breakout groups on Thursday to discuss that article. So are there any questions about the announcements or the way the class is being run? Okay. Feel free to leave comments in the chat if you don't want to speak up in class. I will keep a chat window open so I can see if you guys type anything in there. All right, so today we're going to be talking about the COVID-19 pandemic. This is the one we're right smack dab in the middle of. We're still learning a lot about this disease. And because we're still learning about it, some of the information I give you may end up being wrong, but I'm giving you the best information I have as of Sunday when I updated the lecture. So we've been in this pandemic for about 3 years now. Worldwide, we've had 670 million cases, which is about 8.5% of the entire population. And at least 6.7 million deaths, but possibly as much as 29 million. It's very hard to get accurate information. A lot of countries do not even keep track of that kind of stuff. They literally don't collect information on people's deaths. They don't have death certificates or anything like that. The fatality rate worldwide right now is about 1%. So 1% of people who get COVID will die from it. Again, we're making some assumptions about deaths and numbers of cases. In the US, we've had about 102 million cases, which is about 1 out of every 3 people in the US population. This is probably a very significant underestimation. So, for example, I'm recovering from COVID right now. I got it at the beginning of January. And I didn't go to an official testing center to be tested, and I didn't report it to anybody. My husband got it. He called his doctor, and we kind of used the doctor's advice for how to treat it. So if I'm not reporting it, I'm willing to bet that a lot of people are not reporting it. So when I say that's a severe underestimate, I think that's a pretty fair thing to say. Deaths are at least 1.1 million. So this is 1 out of every 300 Americans. So 1.1 million, that's a big number. William, yeah, go ahead.
Now, if, like you said, a lot of people aren't reporting it, wouldn't it be fair to say that the estimated deaths from COVID would also be significantly lower?
Yes, you're absolutely right. Even in the US, where we have death certificates, a lot of coroners, the people who write the death certificates, they may put severe pneumonia instead of COVID, because pneumonia describes the symptoms that usually cause deaths. And we also see people who are dying not necessarily of the acute infection, the respiratory infection, but instead they die within a year of being infected of something like a heart attack or stroke. COVID causes your clotting system to not work correctly. And if you get clots in your heart, that's a heart attack. Clots in your brain, that's a stroke. So yes, you're absolutely right. We think this is a massive underestimate.
That's not exactly what I meant.
Oh, okay.
I was saying, so you said the death percent was around 1%?
Worldwide, yes.
Worldwide, around 1%. So if people get COVID, don't tell anyone, and then recover, wouldn't the death rate be lower?
Yes. Yes, that is definitely a possibility. However, we think the number of deaths being reported are also low. So both the numbers of cases and the numbers of deaths are probably lower than the accurate, the actual numbers. So you're right, we don't have a great estimate, excuse me, we don't have a great idea of what percentage of people who get COVID die from it. Absolutely right there. We do have better information in places like Europe and the US, and those places kind of support the 1% fatality rate. But there's some variability based on what percentage of the population is vaccinated. So higher vaccination rates drastically reduce the mortality rate, which I've got a slide on that a little bit later. Okay. So as I mentioned, one of my neighbors is coming over. As I mentioned, the rate of death in the US is down to at least 1%, quite possibly lower, as you pointed out. In March of 2020, over 6% of people in the US who got COVID died. And we were doing much more testing at that point, and we had much better numbers from that point. So it's not nearly as bad now. We've learned how to treat people, which reduces the risk of death, and vaccination significantly reduces the risk of death across all ages. If we look instead of deaths that have been reported as COVID deaths in the US, we can look at something that we call excess mortality. Excess mortality is a number that looks at how many people have died over a time period and compares that time period to the, in the case of COVID, the previous decade. So you can look at what percentage of the population died every year for the decade before COVID and compare it to COVID times. And in the US, we find an excess death rate of 1.4 million. Now, it's complicated because in addition to COVID, we've been seeing higher rates of drug overdoses. We've seen higher rates of suicide, and some of these deaths were due to hospital overcrowding. In the US, our hospitals are a for-profit system, and so they're designed to be nearly full all the time because that's the way you maximize profits. So if they're designed to be nearly full and we have something like a pandemic with like we had with COVID, the hospitals are going to be overwhelmed, and people who have other conditions may not get the best care that they could get, and might end up even dying because there's not enough doctors, not enough nurses, and not enough hospital beds.
I have another question about that.
Yeah.
So, all the tests spike typically between like December, like November to February. Do you think that's because people do test before the holidays? And then like the COVID spikes are probably more leveled out, but people don't know because they're not testing regularly.
I'm sure there's some of that. However, if we look at other winter illnesses, other head cold type illnesses, they tend to spike in January.
Okay.
Which if you look at the graph, you can see these spikes tend to be more, right before where it says February. Spikes are in January because during December, we're all getting together with a lot of people, a lot of traveling goes on. When you travel, you carry the illnesses from your area to a different area. So I live in California. The diseases that are circulating out here in California, I've been exposed to them. They're not a big deal. Whatever the cold is, I can get over it. But if I fly to Massachusetts, it's something that people in Massachusetts have not been exposed to. And so they're more likely to get sick during that time of the year. And the school holidays also play into this. You tend to see an increase in diseases at the beginning of each semester. Does that clear things up for you, Eric?
Oh, yes, it did. Sorry, I muted myself. I didn't
Okay,
know that.
no worries, no problem. Sam, you've got your hand up?
Yes. So that's interesting that you mentioned that, because I really, definitely the flu this year was really, really bad as well.
Yeah.
And I definitely noticed that, I feel like the intensity of the flu was stronger than it has been previous years. Like, I know most of my family members got the stomach bug and the flu this year, and it was really bad.
Yep. A lot of that is the fact that we haven't had bad flu outbreaks for the past few years. And so we don't have much immunity stored up. So this year it was absolutely much worse than normal.
Would that be also because COVID was the dominant illness being spread? Why flu was less spread in the past couple years, and now?
Yeah, a lot of that is due to masking. So in 2020, everybody was masking a lot, and schools were going virtual, and so people weren't mixing as much. Even in 2021, we saw some of that. But now everybody has gotten sick of the flu or sick of wearing masks. And so this past year, that's one of the reasons we got the flu so bad.
All right.
Any other comments or questions on this part? You guys had some good points. Okay. When we look at the history of deadly pandemics. Hi, Nutmeg. Sorry, my cat just walked in the room. You probably hear him. He's going to fuss for a few minutes and then want me to pet him. Okay. If we look at the history of deadly pandemics, we can arrange these in terms of severity in a couple of different ways. If we look at total numbers of deaths, right now, COVID is number 5 on the list. So there have been 4 pandemics that have killed more people than COVID. And again, you're absolutely right in your point, the point made earlier that we don't have great numbers. We don't have great numbers for any of these pandemics. But as far as we can tell, this is the 5th deadliest in terms of total deaths. In terms of percent of population, COVID is way down on the list. It's down to about 12th place. So it's still a very significant pandemic. But our best estimate is that we've lost 0.1 to 0.4% of the worldwide population. That's still severe. But if we compare this to the Black Death, which we'll be talking about after spring break, our estimates for the Black Death are between 17 and 50% of the worldwide population. That's a pretty wide range. We know that in Europe, the death rate was about 50% of the European population. The question that we can't answer is how far was this disease spread? Did it spread all throughout Asia? Did it spread into Africa? And we don't have good ideas of the population of the Americas during the Black Death. Now, there are a couple of reasons that are very frustrating to scientists that have made COVID be more severe than it could have been, especially in the US. So in other industrialized countries, places like Europe, Australia, New Zealand, the kind of the Western world, governments are supporting people staying home sick. They either are directly paying people what their salary would be if they were going to work, or they require employers to pay people sick leave. We don't do that in the US. And a lot of people in the US, our economy is not great. And a lot of people, if you miss a week of work because you're sick, you're going to have trouble buying groceries or paying the rent. So people in the US tend to go to work sick. These other Western countries also tend to have a public health care. Healthcare in the US is a private service, so you have to have insurance. You often have big co-pays. It's often very expensive to go to the doctor, especially if you don't have insurance. So people tend not to go to the doctor and get healthcare. We're starting to see even pretty much everywhere around the world, we're seeing declines in masking. So wearing masks in public is a cheap and very effective way to reduce the risk of spreading this disease. The US, we don't have great vaccination rates. If you look at countries like New Zealand and Australia, they have very, very high vaccination rates. And their rate of disease and deaths from COVID is much, much lower than the US. We have a lot of anti-vax propaganda in this country, and the government really is not doing anything to try and get the facts out, or if they're trying it, I'm not aware of it. So, we've got that concern. I am going to explain how vaccines work a little later in the semester, so you guys will know the facts about vaccination. Our government is also not doing a great job at recommending things that we can do to reduce COVID or reduce the death from COVID. They're really pushing for reopening the economy. We've got to keep the economy rolling. My question at this point, what is the economic effect of 1 out of 300 Americans dying in the past 3 years? I think a lot of us can see this. We can see this in supply chain issues, increased costs. And we also have people in this country who are spreading propaganda that COVID really isn't that bad. Well, it's much worse than the flu. I've had the flu. The flu's nasty. I've had COVID. COVID is nasty. Now I'm fully vaccinated. I am completely up to date. I have had every vaccine that I have been allowed to have for COVID. And even so, I was wiped out for 2 weeks. Last time I had the flu, I was wiped out for about 1 week. And you can probably still hear my voice is still pretty rough. And this is like 4 weeks after I started to get sick. So let's talk about the virus COVID. This is a false color electron micrograph image of the COVID-19 virus. So these are the actual virus particles. Viruses are incredibly small. It's hard for us to comprehend just how tiny these things are. You cannot see them with a standard microscope. You have to use a fancy microscope that, instead of using light, uses electrons. So they're teensy tiny, and they're very, very simple. There's going to be a protein coat, this outer layer, and inside there's going to be some genetic material. And there might be a few enzymes. And that's it. That's all there is to a virus. Viruses are not living organisms. If you've got a virus and you've got it in, let's say there's virus in my coffee mug here, it's not doing anything. Bacteria can grow and reproduce. I put sugar in my coffee, so they've got a food supply. They can grow, they can reproduce, they can move around. Viruses cannot. They are incapable of movement. They are incapable of reproducing unless they infect a host cell. They're just inert. COVID is what we call a coronavirus. If you look at the surface of the virus, you can see these spikes kind of around the edges. The original electron micrographs, somebody thought they looked like a crown, so they used the word corona. We also use the word corona when we describe kind of the same structure around the sun. When the sun looks like it has rays coming out of it, don't look at the sun directly. But when it looks like that, that's called the corona. The group of coronaviruses is very widespread. It's widespread in people, it's widespread in animals. Some cases of the common cold are caused by some coronaviruses. There's about 4 or 5 of them that cause the common cold. We've had a couple of other serious coronaviruses, SARS and MERS, that we're going to talk about in just a second. So coronaviruses, they're found in pretty much all mammals: dogs, cats, rodents, primates, bats. People who, somebody put a YouTube channel. I'm not familiar with that one, but I'll check that one out. People who get exposed to wild animals or feral dogs and cats will frequently get infected with one of their coronaviruses. Usually, it's not a very successful infection. It doesn't cause a lot of symptoms. Maybe it causes a common cold type symptoms. We know that this happens a lot because we can look at people's immune systems. And we can look for antibodies against various coronaviruses and identify that people have been exposed. The most common animal to have coronavirus spread into humans is from bats. Why? Does anybody have any idea why bats would be a common source of infection in people?
Bites.
Bites?
Like I know a
Actu-
lot of people who are bit don't even know unless they have like bats in their house and stuff. So
yeah, you're absolutely right. You can be bitten and not know it. Any other guesses? Okay. So yes, the fact that bats can bite you and a lot of people never know about it. That's definitely part of it. Part of it is that bats live in very large colonies and in very crowded conditions. Anytime you have large numbers of animals in crowded conditions, you're going to have an increased spread of disease. So we see this in poultry farms. Chickens tend to be in relatively crowded conditions in poultry farms, and you may have noticed the price of eggs have gone up. That's because there's a bunch of diseases spreading through chickens this winter. People do the same thing. People in cities get exposed to a lot more diseases than people who live in little small towns out in the country somewhere. The other thing that bats do, and people do, is they travel long distances. Bats can fly, so they can move around, they can go from colony to colony, and they take their diseases with them. Just like people, when we move around, we take vacations, we go visit family, we're carrying our diseases with us. There's another very important reason. And this last reason is that bats make up 25% of all mammal species. 1 out of every 4 mammals is a bat. There are lots of them. Even if you don't see them, even if you're not aware of it, they live pretty much everywhere, and there tend to be lots of them everywhere. As we'll see when we talk about the plague, the only mammal that tends to spread diseases to people at a higher rate than bats are the rodents, mice and rats. And that's because there are twice as many rodents, twice as many mice and rats as there are bats. Half of all animals are either a mouse or a rat. Okay. All right. So this is a chart that was made in March of 2020. I have gone in and updated some of the information, but I want to talk about the history of coronaviruses and be able to compare that to flu. So there's going to be a lot of very unfamiliar stuff on this table. All right, so we have COVID-19. That's our current pandemic. We have SARS, which is another coronavirus, another relatively deadly coronavirus, and MERS, another relatively deadly coronavirus. So we'll start out by looking at the R0. If you look at the second row here, you see R0, basic reproductive number. The R0 is a way of measuring how contagious a disease is. So if we look at flu, it's got an R0 of 1.3. That means that every person infected with the flu will infect 1.3 other people. Obviously, we're not infecting a third of a person, but as an average. COVID's R0 is estimated to be between 2 and 2.5. When we had the Omicron spike, Omicron had an R naught of about 7, which means every person who had the Omicron variant of COVID could give it to 7 other people. We don't have data on the current, the new variant of COVID. So, you know, this is our best estimate for COVID as an overall disease. SARS had an R naught of 3, and MERS has a very low R naught. Most people who have MERS do not give it to anybody else. And when we talk about it, we're going to see that most of these people who catch MERS from another person catch it in a hospital setting. The next number is the case fatality rate. This gives you a rough idea of what percentage of people who catch the disease will die from the disease. As we talked about earlier, this is an estimate. Flu has a relatively low case fatality rate. When it's severe, it's up to 1 out of 1,000 people will die of flu, who get the flu. COVID originally was much, much higher. Our current guess at this is around 1%. SARS and MERS, we have better numbers of because we have a better understanding of how many people got both of these diseases. And so for SARS, the case fatality rate is about 10, which means 1 out of 10 people who get SARS will die from it, which is nothing compared to MERS, where it's about 1 out of 3. Thank goodness MERS has a very low reproductive rate and is not contagious between people. The incubation time refers to how long from exposure to onset of symptoms. Flu is 1 to 4 days. It's pretty fast. COVID tends to be more towards the 14-day range. Again, this is data as of March 22, so we're more confident that it's about 2 weeks after exposure. SARS is about a week, maybe just a couple of days, and MERS is just under a week. If we look at hospitalization rate, flu, about 2% of people who get sick with flu will be hospitalized. COVID-19, this is not an accurate number. This is an accurate number for the first few months of the pandemic. It's much lower than that now, and I don't have a good estimate on what that is. SARS and MERS, most people who get these 2 diseases end up in the hospital. The last row down here looks at annual infected globally, infected in the US, and deaths in the US. So every year, about 1 billion people worldwide, which is the population of the planet now is about 7.8 or 7.9 billion. So that's 1 out of every 7 or 8 people. In the US, we have between 10 and 45 million cases, and we have between 10,000 and 61,000 people who die in the US every year from the flu. COVID has not been around long enough, so we can't get good numbers on it. The numbers that I was looking at over the weekend vary dramatically between 2020, 2021, and 2022. So 2020 and 2021 seem to be worse in terms of death rates. 2022, the death rate seems to have gone down. So with only 3 years, you can't get a good average. As of 2003, there were 8,098 cases of SARS. SARS stands for Severe Acute Respiratory Syndrome. SARS spread very quickly worldwide, caused high fevers, pneumonia, and frequently diarrhea. The mortality rate for SARS, if you were under 60, was 10%. So these are young adults. I don't know about children. I don't know how many children got it, but young adults, mortality rate 10%. People over 60 had a mortality rate 50 to 60%. Fortunately, the total number of cases, the updated number I found this weekend was 8,422. It was contained by the use of strong public health measures and was eliminated in humans by January 2004. It took 14 years to find the source of the SARS pandemic. And that was eventually found by looking at coronaviruses in bat populations in the Yunnan province of China. And we found the virus that clearly ended up causing SARS in humans. Okay, MERS stands for Middle Eastern Respiratory Virus or Respiratory Syndrome. It showed up in 2012. It is mostly spread to humans from camels. There is some evidence that a lot of people get infected and do not develop severe infections. But if you do get severe infections, the symptoms are similar to SARS and COVID-19: fever, shortness of breath, sometimes diarrhea. There have only been 2,600 confirmed cases of MERS. My information is from January 21, but that has resulted in at least 866 deaths, which is a fatality rate of 1 out of every 3. MERS is still around. It doesn't transmit well between humans, so it hasn't spread. And it's the only time it spreads between humans is when you have someone who is seriously ill and they're in a hospital setting. Okay. So how are we doing with this? I know I'm throwing a lot of numbers out at you, but I'm giving you, I'm hoping that you get the understanding that there's a lot of coronaviruses. There's a lot of, some of them are very mild, some of them are very severe. Thank you for the thumbs up. Now I want to talk about something called Event 201. This happened in 2019, and it was a group of experts on viruses, on epidemics, that did what's called a tabletop exercise. Tabletop exercises are when a bunch of people who are very knowledgeable about a topic get together and discuss worst case scenarios. My mom worked in facilities management, and she would often go to these tabletop exercises where they would say, what happens if a hurricane hits? Let's talk about the risks. Let's talk about what we would do in response. So it's kind of looking at worst case scenarios and trying to come up with plans in case those happen. Event 201 was looking at pandemics. And since we had already seen SARS and MERS, those had both come out both been relatively deadly, but not spread very far. They decided that they were going to use a coronavirus pandemic for their tabletop exercise. They said it was going to start in bats, it was going to move into pigs, and then into people. This is very common, especially with diseases from bats. They'll often jump into another animal before they jump into people. We think that happened with COVID-19. We think it spread from bats to other animals and then into people. They set up a bunch of computer simulations, discussed best practices. They used SARS as a model, but increased transmissibility between people. The scenario that they ran lasted for 18 months. Well, COVID has sure lasted longer than that. It resulted in 65 million deaths and eventually slowed down. This was before COVID. Before COVID. They said that it would eventually slow down when 80 to 90% of the world population had been exposed, and then it would be a disease of childhood. Well, they got some things right and some things wrong. We did end up with the coronavirus pandemic, less than a year after they talked about the scenario. Fortunately, COVID is not as deadly as SARS. It's not as deadly as MERS. We talked at the beginning about how the death rate is probably wrong. But if we look at death rate from COVID in countries that have pretty accurate statistics on cases of COVID and deaths from COVID, this data is from 2020, 2021. So it wasn't last year. It was during the time period when we were testing a lot more. In the US, the death rate for COVID is 3.3 per 1,000 people. So we're not even looking at how many people got infected. We're just looking at how many people died per 1,000 people. Let's compare this to some similar countries. France, 2.5 per 1,000. Canada, 1.3 per 1,000. We're not looking very good. Australia, I mentioned Australia has a very high vaccination rate, 0.7 per 1,000. New Zealand, high vaccination rate. They did a great job at the beginning of the pandemic, shutting things down, paying people to stay home, 0.5 per 1,000. If you want to look at countries with higher death rates, there are some out there. England is pretty close to the US. A lot of the places that are higher than the US are not what we call Western countries, but in places like India and Africa and poor countries in Asia. Okay. So that's kind of the history of COVID. It was really shocking that we had this tabletop exercise, and within less than a year, we had a pandemic that almost mirrored that tabletop exercise. They picked a good option there. All right. On the left, these are your lungs on COVID. So if you're not familiar with X-rays, this is the spinal cord coming down here in the center. This is the heart. mostly off to one side, a little bit on this side. This big white area below is the liver. These curved lines are ribs. And you can just start to see the shoulder right here. So if we look at the image on the right, this is after COVID. The lungs should be relatively dark on an X-ray. This white stuff is signs of some damage. You will see some white lines that are blood vessels, but mostly it should look very, very dark. If we look at the COVID, look how much white there is. That is all infection. These are electrodes that they are using to monitor this patient's heart. So COVID causes coughs, fevers, shortness of breath, muscle and body aches, loss of taste or smell. My husband lost his sense of smell when he had it. I didn't, but I got the diarrhea instead. I know, too much personal information. All of these symptoms can occur in what are called mild or moderate cases. And the symptoms can last for weeks or even months. What we know COVID is doing to the body, part of it is causing clots, relatively small clots, but clots within blood vessels, which is not where you should get blood clots. Anywhere you get a blood clot in your blood vessel, you can get damage to that organ. So if you get blood clots in the blood vessels on the back of your hand, that's not really a big deal. But if you get blood clots in your liver, your heart, your brain, your kidneys, you can cause a lot of damage there. We now know that there is a long COVID. Even mild cases have a risk of lingering symptoms that last after there is no evidence of the virus left in the body. Long COVID can be fatigue, headache, cough, joint pain, shortness of breath, and what's called brain fog. So a difficulty in concentrating, difficulty in decision making. We have no idea how long COVID has the potential to last. Some people improve slowly. Some people seem to have it. There are some people who got COVID in 2020 who still have long COVID symptoms, especially things like fatigue and the brain fog. Even if you're vaccinated, you have about a 5% chance of having longer term symptoms. The more times you have COVID, the more likely you are to have long COVID symptoms. So even if you've had COVID, you still want to try not to get it again because you have an increased risk of this. We don't have a good handle on what causes these long-term symptoms. If you look at the syllabus, we're going to talk about post-viral syndromes. Long COVID is a post-viral syndrome. We're going to talk about those, what we do know about them. We know about long COVID, but it turns out that there are other diseases that seem to be related to having been exposed to a specific virus. Things like multiple sclerosis can be triggered by certain viruses. And we'll talk about that towards the end of the semester.
So for other like sicknesses or viruses, are there long-term effects that we know of? Like for common things like the flu?
There
Like
are,
why is it just COVID?
it's not just COVID.
Yeah.
It's just that we've only really started to grasp and understand this in
Mhm.
the past few years. Long COVID is relatively obvious, and because it happens right after you have COVID.
Yeah.
Why that is, I couldn't tell you. But these other symptoms or syndromes that show up, that might show up after you've recovered from an illness, chronic fatigue syndrome, multiple sclerosis, a lot of autoimmune diseases, those show up after a period of time, after a few months or years after you've had the infection. We don't understand the difference. COVID's only been around for 3 years. We've only accepted long COVID as a real thing for maybe 2 of those years. It's just not enough time for science to figure out the answers to this.
Yeah, because I was like wondering, like with the flu, like you don't really hear about people having any sort of long-term effect. So I was wondering why that was different with COVID, because you don't really hear about that in other sicknesses. You know what I mean?
Yep, and I wish I could answer you, but science doesn't know yet.
Yeah. Okay, thank you.
You're welcome. Okay, so let's talk about our current understanding of the disease process. So this is going to be more molecular stuff than you probably want to know, but this is brand new information. We've literally just figured this out in the past 6 months to a year. So the virus, remember these long proteins that stick out on the surface? Those are called spike proteins. And the spike proteins bind to what's called a receptor on the surface of the cell. A receptor is simply a protein on a cell surface that receives material or information for the cell. And let me spell receives correctly. It can have a few other functions as well, as we're going to see. This particular receptor does have a secondary function that we're going to talk about, but they're really designed for things to attach to. So the spike protein attaches to this receptor called ACE2. Once it attaches to ACE2, that triggers the cell to bring in the virus. So anything that attaches to ACE2 is brought into the cell. So COVID is hijacking this system to get inside the cell. The spike protein acts as a key. We can think of ACE2 as the lock on the door. ACE2 is a very, very common protein. It's found on epithelial cells. So epithelial cells, fancy word. These are cells that are exposed to the environment. Your skin is made of epithelial cells. Your skin, as far as I know, doesn't have a lot of ACE2. But the inside of your mouth, your throat, your lungs, your digestive tract, those surfaces all have this ACE2 protein. They have a lot of it. ACE2 also lines the inside of blood vessels. What ACE2 normally does is it regulates blood pressure and inflammation. So your body tries to maintain a steady blood pressure, and it tries to maintain a reasonable level of inflammation. Inflammation is caused by any kind of infection or response by the immune system. There are things that stimulate inflammation in response to infection. ACE2 turns that response down. You want just enough of a response from your immune system. If your immune system is over responsive, that's going to cause damage to your body. So one of these compounds in the body is called angiotensin 2. I know, fancy name. This is a protein that increases blood pressure. So if your blood pressure falls too low, or if your blood oxygen supply falls too low, your body releases this compound to make angiotensin 2. Angiotensin 2 then can increase your blood pressure so that oxygen gets around your body the way it's supposed to. But angiotensin 2 also causes inflammation in response to an infection. ACE2 binds to angiotensin 2, brings angiotensin into the cell where it's now broken down. So this prevents inflammation from lasting too long, and it prevents your blood pressure from going up too high. Everything in the body has a balance that has to be maintained. If your inflammatory response lasts too long, it causes something, fancy word, cytokine storm. Whoever named that was a pretty good one. You may see this in news articles. It's a common, very nasty effect of infection with COVID. We see it in other diseases as well. And it's basically too much inflammation. And this too much inflammation causes injury to the lungs. It causes your blood vessels to leak. So material from inside your blood vessels leaks out, which is not a good thing. So when COVID binds to ACE2, ACE2 is now not available to bring down that level of angiotensin 2. So we have a higher level of angiotensin 2 than we should have, than is healthy. Do you guys understand that? I know that's a complex series of things and some unfamiliar words. Did anybody understand it? Did everybody go to sleep? Okay, a complete lack of response. I'm going to keep talking. We can also look at the psychological effects of COVID. People who are psychologically impacted include patients, lots of medical professionals. Ooh, somebody got it in bio class. Cool. People may be impacted by the pandemic, even if you're not directly affected by it. If you know somebody who's had COVID, or if you're just afraid of getting COVID. So we're seeing an increase in things like PTSD, post-traumatic stress disorder, depression, anxiety, difficulty concentrating, reduced productivity. I know I've had difficulty concentrating and reduced productivity during this pandemic. Long-term fatigue. Again, this is a psychological fatigue, not a physical fatigue. And of course, financial difficulties. Employment, a lot of companies went under early in the pandemic. People lost jobs. If they have to take off time sick, that can cost you money. So there's a lot of things that can go on that are caused by COVID without causing the disease. All right. This was written by a friend of mine early in the pandemic. Peter is a scientist, a biologist who does have a special interest in bats. He's really focused, he's really an entomologist, but he just spends a lot of time looking at bats because he likes bats. As the coronavirus panic sweeps the globe, everybody focuses on finding the culprit. There is some evidence that the reservoir of the virus, that means where the virus came from, might have been horseshoe bats in China. It is therefore important to keep in mind that these awesome animals did not invade our living spaces. We did theirs, and now we have to deal with the consequences. This is going to be a recurring theme. People moving into wilderness areas and now having a higher rate of interaction with wild animals. That is one of the things that can start a pandemic. If we leave enough natural habitat for other organisms and restrain our desire to steamroll through the world, epidemics and other environmental disasters will become much rarer. These straw-colored fruit bats in the picture lived in Tunduru Gardens in Mozambique, which is where Peter does most of his research. He lives there about half the year, and have probably lived there for thousands of years, long before people built a wall and a mountain range of buildings around them. We do know that COVID originated in China. There is strong evidence that it came from bats. When we talk about viruses, we're almost out of time. When we talk about viruses, viruses evolve very quickly, especially the RNA viruses. So, you know, our genetic material is in DNA. Some viruses have DNA, but others just use RNA. RNA is not as stable as DNA, and there is an enzyme called RNA polymerase in viruses that copies the RNA. So that enzyme makes duplicate copies of the virus's genetic material. This enzyme has a high error rate. And viruses make thousands to millions of copies of their genetic material. So a lot of the viruses that are produced have genetic mutations. But if you're producing 1 million offspring, and half of them have genetic mutations that basically make them non-functional, so what? You still produced 500,000 offspring. That's a hell of a lot. So they can afford a lot of mutations. And most mutations in viruses are harmful. But sometimes these mutations will be beneficial. And beneficial means increased transmission, ability to evade the host immune system, or the ability to infect new organisms. Okay. I think there's where we're going to stop. Does anybody have any questions on what we've covered today? Questions about COVID in general?
No, but I do have a question about the homework.
Okay.
So the one from previous week was due, I'm assuming, this class?
Technically, I say midnight on Sunday.
Okay, and then I'm assuming if that's the case, then the homework assigned today will be just same thing?
Yes. I try and set up all assignments to be due midnight on a Sunday.
Okay, thank you.
You're welcome. All right, if that's it, I will see you guys on Thursday.
See you then. Thanks.
Thank you.
Bye.
Thank you.
Bye.
Bye. Thank you.
you.